Good day all. Today we'll be looking at a question under block diagram reduction. Now our question says, what is the overall transfer function of the given block diagram? It is demanding for the overall transfer function of the given block diagram. Okay, so before we start solving, we have to look at the system first and find a part that we can reduce. For instance, we could reduce this because they're connected in series, but this is in between them, so it won't work. There is a branching point in between them. So it's either we move this branching point before we can join these two together. Then this is a feedback loop. We can fix this as, when we join this, we can fix this. Any other thing again we can. Okay, so as we proceed, we'll get more idea on what to do. Solution. So our first action will be to move this branching point. So are we going to be moving it forward or backward? If you move it forward, it won't give us the feedback loop that we want. We want it away from this feedback loop so that when we join these two, we can then find the feedback loop here, the feedback loop from transfer function. So we're going to move it away from this loop. Let's say we're going to be putting it here. So when you do that, you will have your diagram to look like this. Since we are moving forward, our branching point is now going to be having a division sign over the one that we crossed. So I will advise that before you watch this video, this particular one, that you revisit the rules in block diagram reduction, because in case if you're wondering why this is so, it was explained perfectly well in that video. So that is that. So these are in parallel, these are in series, these are also in series. So we can rejoin them, and when we do that, this will multiply this. When we do that, we have H1 over G3. This will multiply this, and we will have G2 G3. That's for those in series. So we have multiplied them to get this. Now this is now a complete feedback loop. So using our feedback knowledge, this is plus and minus. So using our feedback knowledge, we are going to replace this part we'll be having a transfer function here. Now this transfer function will be G, because of we are having what plus here, G what G2 G3. Why is it G2 G3? They are the one that are on the main parts, the open loop parts. They are the one on the open loop parts. So that is the reason why we're using them and not H2 on top that was on top. Now all over 1 plus. It is plus because here is what? Minus. The one on top, you repeat it again, G2, G3. Now you then include your multiplied by your HZ, which is the feedback loop. So this is what we are going to be getting if we are to find the if we are to reduce that feedback loop. So we have this. So like I said earlier, in case if you're confused on how this came to be, it's just application of the formula that we made emphasis on earlier. In one of the videos we made emphasis on it. So you look at what's on the closed loop part, make it your numerator, over 1 plus or minus, depending on whether your summing point, if you're having minus or plus. If it is minus, here will be plus. If it is plus, here will be minus. Then the one on top again will repeat itself, multiply by the transfer function loop, the feedback loop transfer function, which is H2. So when you do that, you get this. So as you can see, we have reduced this one to 1, push this this branching point towards this part. Then we had a free feedback loop that we just joined to get this. Now this and this are in series, so we can also simply just multiply them. And when we do that, we have G1 here in front multiplying the whole of this, and this will go, and this will go. This will go. Now this and what? They're not in parallel, but what? A feedback loop. As you can see, this is our open loop part. This is the straight line part. The main part is going on its own. Then we're not tapping from the output, and this is a transfer function here. So this is a feedback loop. So we are going to be applying the same principle that we did for the earlier parts. Now we have to simplify it. So because of that, I will be kind of cleaning it. So we are having that, the one on top, G1, G, G1, G, 2G, 3 over 1 plus G, 2G, 3, H2 all over 1. Like we said, is going to be what? Minus, because here is what? Plus. Now this, which is what? G1, G2, G3 over 1 plus G2, G3, H2. Does this multiply by this guy, which is what? H1 over what? G3. These two are multiplying, meaning that this guy can cancel out this guy. So if we do that, we can also find the LCM of the general LCM of this whole expression. This is the numerator. This is the numerator, and this is the denominator. So focusing on the denominator, we have cancelled out G3. We can also make all these so as we cancel this G3 now, if G3 is to go out and G3 is to go out here, our bracket is now to reduce, we're going to be having something like this, H1 here, because H1 will be multiplying, this will be off. So this is what we'll be having as our answer after cancelling the G3. Now, since we're having 1 here minus, we're going to make this now a linear equation where all the denominator is divided by this. So that means we'll be multiplying this guy, or we can simply just say the LCM of this is what? Of the denominator, focusing on the denominator now. On the denominator, we're leaving that one apart first for now. Focusing on the denominator, LCM of the denominator, we can take it to be this, which is 1 plus G2 G3 H2. Now this will divide this. We have this multiplied by that. We'll be having, let's repeat the same thing, G2 G3 H2 minus G1 G2 H1. So we can replace this denominator with this value. When you have found the LCM, you can now replace the whole of the denominator with that value. Okay. Now, let's say this is our denominator now. This is our denominator. And this is our numerator. Now, we can still twist our denominator, so that this one on top will multiply this one down will multiply the one on top. So like you having 1/2 divided by let's say 2/3. This, you can also write this as what? 1/2 divided by what? 2/3. And we know that in maths, when you change this to multiplication, this guy will twist, and when it rotates, you'll be having what? 3/2. So this is what we're going to be doing here. We're going to rotate, twist our own, get our multiplication sign. This one will be multiplying this one, while this one will be multiplying this one. Similar thing that occurred here. So when we do that, we having something like this. This was previously our numerator. I just wrote it down here so I could rearrange it. So we are having G1 G2 G3 over this. I wrote this over here, multiplied by this guy will now be on top and this guy will now be below. And from what we are seeing here, this and this are the same. 1 plus G2 G3. Okay, there's a mistake here. This is H2. This is H2 from here. So as you can see now, they are both the same. So this can simply cancel out. And when they do, we'll be left with just this expression. We'll be left with this. So the math here is just bogus. It's not difficult. So long you just do some few manipulation, you can just simply get your answer. So this is going to be our new transfer function for here. So we are going to be removing the whole of this and putting this in place. So the whole of this is going off. Then we have G1, G2, G3 all over 1 plus G2, G3, H2 minus G1, G2, H1. So this will be our new what? Transfer function. So that will be our new what? Transfer function. Now we have reduced it to another closed loop again, but this time around we don't have a H towards this part. So this one is not a feedback loop but just a closed loop on its own. And in this case, if we are to have something like G and your summing points, this entering, let's say plus and minus, this going, now you're tapping from here to what? Here. So at this point we say that our what? Feedback and transfer function is what? Unity. The value is 1. So our transfer function, which is the ratio of the output to the input, C over R, is going to be the one on the main part as usual, G, and it is G because here is what? Plus. If here was minus, it would be minus G. Now 1, is it going to be plus or minus? It's going to be plus because here is what? Minus. 1 plus G only, no H again, because there is no what? Feedback transfer function. So that's what we're going to be doing here. We're going to be doing this for this. So for us to solve that, okay, so I will like to economize space. So I don't know if it will be good for you guys. Let me just do it like that. So let's say that, let's put it down here. G, let's say that A is equals to what? G1, G2, G3. B is equal to G2, G3, H2. And C is equal to G1, G2, H1. So let us know this. We'll just be replacing this with that. So A is this, B is this, and C is this. So we'll be having here A over 1 plus B minus C. Now that is our what? Numerator all over 1. Is it going to be plus or minus? It's going to be plus because here is what? Minus. Plus A over 1 plus B minus C. The A, remember, like we said there, we just want to economize space. So instead of me to be writing the whole of this expression on and on again, I'm substituting these three products here with A, these three here with B, these three here with C, just to economize space. And as you can see, it has done a very good work for us. So this is acting as our G in the general formula. and see it here, then your plus your 1. So for us to further solve this, we will find a common multiple for this one, the LCM for this one. For the denominator part, find an LCM for it, which is 1 plus b minus c. This will divide the 1 here, which is this times 1. We're going to be having 1 plus b minus c. This divided by this is 1. 1 times 1 on top, we're going to be having what? Plus what? A. Plus a. So we'll be having that our new denominator is what? This is our new denominator. Now, using the same principle, this one will multiply the one on top, while this one will multiply this one. So doing that, we'll be having this one multiplying here. We have brackets 1 plus b minus c over this one multiplying here. We'll be having 1 plus b minus c plus a. So now this is our new expression. This is our new expression. So now from here, can anything cancel out from what we are seeing? Yes, this and this are what? Equal. So this can cancel out this, and we are left with a over what? 1 plus b minus c plus a. C plus a. Now substituting our values into this, we have that our let's now put the answer directly here. So removing the whole of this now putting it now in the reduced form. Now it will simply be this. Now the a being what? G1, G2, G3 all over 1 plus b being what? G2, G3, H2 minus c being minus G1, G2, H1 plus a, which is what? G1, G2, G3. So the whole of this is now our new transfer function. So we have succeeded in reducing the whole of this into this. This is now our new transfer function. So that's all for this. Thank you and God bless you. Please subscribe to the channel, and I will see you in the next video. Goodbye.